Welcome back to KrossUSA channel. From the cutting-edge automation of Swedish precision to a century-old water-powered mill still running strong in the Swiss Alps. Join us as we explore 3 remarkable sawmills that represent the past, present, and future of lumber processing. You're about to witness craftsmanship and technology working in perfect harmony. You know, there's something deeply satisfying about watching raw timber transform into perfectly cut lumber, especially when it's done with the kind of precision and efficiency that only comes from generations of Swedish craftsmanship. Today, we're taking you inside the Soderham Ericson sawmill, a facility that represents the very best of Scandinavian wood processing technology, where tradition meets cutting-edge innovation in ways that would make the old-time sawyers of America's lumber boom era absolutely marvel. Let's start with what they're working with here. The primary species processed at Soderham Ericson are Norway spruce and Scots pine, the workhorses of Scandinavian forestry. These aren't your average pine trees. We're talking about timber that's been growing in the harsh Nordic climate for anywhere from 60 to 100 years, developing the kind of tight growth rings and structural integrity that builders and craftsmen have prized for centuries. The spruce, in particular, is renowned for its straight grain and uniform texture, making it ideal for everything from construction lumber to fine woodworking. The Scots pine brings its own character to the table, with a beautiful reddish-brown heartwood that's naturally resistant to decay. Now, here's where things get interesting. Before a single log ever reaches the main sawing line, it goes through a sophisticated sorting and preparation system that would have been pure science fiction to the sawmill operators of just 50 years ago. As the logs arrive at the facility, they're first directed to the log yard, where they're sorted by species, diameter, and quality grade. This isn't done by hand anymore, folks. Modern optical scanning technology reads each log like a book, measuring diameter at multiple points, detecting defects, knots, and internal characteristics that affect how the log should be processed. The debarking process is the first major transformation these logs undergo. The debarking drum at Soderham Ericson is a massive rotating cylinder that tumbles the logs against each other and against the drum's interior surface. As the logs tumble, the friction strips away the bark without damaging the valuable wood underneath. What's fascinating about this system is how efficient it is. The bark is collected and used as biomass fuel, powering the facility's heating systems, and sometimes even generating electricity. Nothing goes to waste in a well-run modern sawmill, a philosophy that harks back to the resourcefulness of early American lumber camps where every scrap had a purpose. Once debarked, the logs move to the metal detection station. Yes, you heard that right. Metal detection in a sawmill isn't about finding lost tools. It's about protecting those incredibly expensive saw blades from embedded metal. Over a tree's lifetime, it might grow around old fence staples, nails from boundary markers, or even shrapnel from historical conflicts. The metal detectors at Soderham Ericson are sensitive enough to find even small pieces of metal, and when something is detected, that log is diverted for special handling. The main sawing line is where the real magic happens, and let me tell you, it's a ballet of engineering precision. At Soderham Ericson, they use what's called a chipper canter system for the first pass. This machine is a marvel of efficiency. As the log feeds through, it makes 4 simultaneous cuts, removing the rounded outer portions of the log and creating a square or rectangular cant. But here's the clever part. Instead of producing waste slabs, those outer portions are immediately chipped into wood chips that are sold to pulp mills. Every bit of that tree becomes a valuable product. The cant that emerges from the chipper canter then moves to the gang saw or multi-blade system. Imagine multiple circular saw blades mounted on a single arbor, all spinning in perfect synchronization, all cutting simultaneously. At Soderham Ericson, these saws are positioned with computer-controlled precision, adjusted for each cant based on the initial scan data. The system knows exactly what size boards will yield the most value from each piece of wood, and it sets up the cuts accordingly. We're talking about tolerances measured in millimeters. The kind of precision that was unimaginable in the days when a skilled sawyer would eye each log and make cuts based on experience and intuition. The speed of this operation is breathtaking. Logs that would have taken hours to process by hand in the old days move through this system in minutes. But speed isn't the only advantage. The consistency is remarkable. Every board that comes off this line meets exact dimensional specifications. When you buy a 2x4 today, and it's actually consistent from one board to the next, this is why. The technology at facilities like Soderham Ericson has revolutionized construction lumber, making modern building methods possible. After the main sawing operation, the boards enter what's called the trimmer line. Here, optimizing saws trim each board to standard lengths, removing defects and end splits. But this isn't random cutting. Computer vision systems scan each board in real time, identifying the clearest, highest quality sections. The trimmer saws then make precise cuts to maximize the yield of premium grade lumber while cutting away defective sections. Those cutoffs aren't wasted either. Shorter pieces go to other product lines, and anything too small for lumber becomes wood chips or biomass fuel. The grading system at Soderham Ericson represents another leap forward in lumber processing technology. Automated grading scanners examine each board, looking at knot size and frequency, grain patterns, splits, and other characteristics that determine lumber grade. In the old days, this was done entirely by eye, by experienced graders who could walk down a stack of lumber and sort it by grade based on years of training. Now, computer vision systems can do this work with incredible speed and consistency, though many mills still employ human graders to verify the computer's decisions and catch anything unusual. Once graded, the lumber moves to the sorting system, and this is where the sophistication of modern sawmill operations really shines. The boards travel down conveyors, equipped with drop gates and diverters. As each board passes sensors that have read its dimensions and grade, the control system activates the appropriate diverter, sending that board to the correct bin or stack. You might have stacks being built for different widths, different lengths, different grades, and different customer orders, all being sorted simultaneously and automatically. It's like watching an incredibly complex game of three-dimensional chess being played at high speed. The final stage for much of this lumber is the kiln drying process. While kiln operations might seem straightforward, they're actually among the most critical and sophisticated parts of the entire operation. The kilns at Soderham Ericson are computer-controlled chambers where temperature, humidity, and airflow are precisely managed to reduce the moisture content of the lumber from around 60 to 80% when fresh cut down to the 15 to 19%. That's ideal for construction lumber, or even lower for specialty applications. This process used to take weeks or months of air drying. What really sets operations like Söderhamn Ericsson apart is the integration of all these systems. From the moment a log enters the yard until finished lumber is loaded onto trucks, there's a continuous flow of information and material. The computer systems tracking each log and board ensure that nothing gets lost, that production efficiency is maximized, and that quality standards are maintained throughout. This level of integration and automation represents the culmination of 2 centuries of sawmill development. From the water-powered up-and-down saws of the early 1800s, through the circular saw revolution of the late 19th century, to the gang saws and band mills of the 20th century, and now to these highly automated, computer-controlled facilities we see today. For those of us who appreciate the history of American industry, there's something poignant about watching these modern operations. The great lumber boom that built America, from the white pine forests of Michigan and Wisconsin to the Douglas fir giants of the Pacific Northwest, was powered by sawmills that were, in their day, just as innovative and groundbreaking as Soderham Ericson is today. The difference is in scale and safety. Those old mills were incredibly dangerous places. The injury and death rates in 19th and early 20th century sawmills were staggering. Today's automated systems have largely removed humans from harm's way while dramatically increasing production and consistency. The Swedish approach to forestry and lumber production, exemplified by operations like Soderham Ericson, also reflects a different philosophy about forest management. Sustainable forestry has been practiced in Scandinavia for generations. For every tree harvested, new ones are planted. The forests are managed as perpetual resources, not as something to be exploited and moved on from. This is a lesson that American forestry learned the hard way after the devastation of our old-growth forests in the 19th and early 20th centuries. Today, American forestry practices have improved dramatically, but there's still something to be learned from the Swedish model of viewing forests as renewable resources that must be carefully managed for future generations. As we watch the smooth operation of this sawmill, with lumber flowing through the system in a continuous stream, it's worth reflecting on how this industry has evolved and what it means for the future of wood as a building material. In an age increasingly concerned with sustainability and carbon footprints, wood products offer significant advantages. Trees absorb carbon dioxide as they grow, and that carbon remains locked in the wood products we build with. Modern, efficient sawmills like Soderham Ericson maximize the value extracted from each tree while minimizing waste, making wood an increasingly attractive material for construction and manufacturing in our environmentally conscious age. Now, let's travel from Sweden's modern industrial marvel to something completely different, yet equally fascinating. In the Rhine Valley of St. Gallen, Switzerland, there's a sawmill that operates exactly as mills did more than a century ago. This is the historic Mädris sawmill, operated by Martin Mach, and folks, stepping into this operation is like walking through a door into the past. For those of us who remember when craftsmanship and connection to tradition meant something, this place is absolutely magical. The Mädris sawmill isn't a museum piece that sits idle for tourists. This is a working mill, still cutting lumber using water power and traditional mechanical systems that haven't changed fundamentally since they were installed generations ago. Martin Mach didn't just inherit this mill. He's become its guardian, keeping alive skills and knowledge that are rapidly disappearing from our modern world. There's something deeply American about this, actually. It reminds me of the craftsmen and small mill operators who dotted the landscape of rural America in the 19th and early 20th centuries, each one serving their local community, each one an expert in their craft. The power source for this mill is pure, elegant simplicity, flowing water. The Rhine River Valley provides a consistent flow that's been harnessed here for over 100 years. The water wheel itself is a magnificent piece of engineering from an earlier age. We're talking about a wooden wheel, probably 15 to 20 feet in diameter, with buckets around its circumference that catch the flowing water. As water fills each bucket, the weight causes the wheel to turn. That rotational energy is then transmitted through a series of gears, shafts, and belts to power the various saws and equipment in the mill. It's the same principle that powered thousands of American mills in the 1800s. From grist mills grinding flour to sawmills cutting lumber to textile mills spinning thread. What's remarkable about water power is its consistency and reliability. Unlike steam power, which required constant attention and fuel, a water wheel just keeps turning as long as the stream flows. The one at Mädris has probably turned millions of times, cutting countless board feet of lumber, and it could keep going for another 100 years with proper maintenance. There's a lesson there about building things to last, about engineering that prioritizes longevity and reliability over planned obsolescence. The primary saw at Mädris is what we call a frame saw, or sash saw. Picture a large rectangular frame holding a straight blade that moves up and down in a reciprocating motion. The log is mounted on a carriage that slowly advances into the blade with each stroke. What makes this system so elegant is its simplicity and effectiveness. That blade, probably 4 to 6 feet long, cuts on the downstroke, powered by the momentum of the frame and the energy transmitted from the water wheel. On the upstroke, the carriage advances the log forward by a precise amount, determined by the thickness of board you're cutting. The wood being processed at Mädris is typically local timber, species that have grown in the Swiss Alps and the Rhine Valley for centuries. We're talking about Norway spruce, silver fir, and European beech, among others. The process starts with log selection and preparation. Unlike the automated sorting at Soderham Ericson, here everything is done by eye and hand. Martin examines each log, looking for defects, checking the straightness of the grain, considering how the log will cut. This is the kind of knowledge that can't be programmed into a computer. It comes from years of experience. From cutting thousands of logs and learning to read wood like a language, he's looking at the end grain, the bark patterns, the way the log sits. And from all that information, he's making decisions about how to position it on the carriage and what cuts to make. The log is secured to the carriage using dogs, metal clamps that grip the log and hold it steady during cutting. The carriage itself runs on rails, driven forward by a mechanical feed system that's ultimately powered by that same water wheel. The sawyer controls the feed rate, the depth of cut, and the positioning of the log, all through mechanical levers and controls that require skill and attention. There's no computer doing the thinking here. Every decision is made by the operator based on what he sees and feels. As the frame saw reciprocates up and down and the carriage advances, you can hear the distinctive rhythm of traditional sawmilling. It's not the high-pitched whine of modern circular saws. It's a deeper, more rhythmic sound, the chunk, chunk, chunk of the blade cutting through wood fibers with each stroke. The boards that come off this saw aren't perfectly uniform like those from Soderham Ericsson. They might vary slightly in thickness. The surfaces might be a bit rougher, but there's character in these boards, a quality that comes from traditional sawing methods. Many craftsmen and woodworkers actually prefer lumber cut this way. The slower cutting speed and the reciprocating action of a frame saw cut through wood fibers differently than modern circular saws, often resulting in wood that's less prone to cupping and warping. For those of us who value history and craftsmanship, places like the Mädris sawmill are treasures. They remind us that progress isn't just about doing things faster and more efficiently. Sometimes, preserving the old ways, maintaining traditional skills, And keeping historic operations running teaches us lessons about quality, sustainability, and connection to our work that we desperately need in our modern world. Let's journey now to the opposite side of the world, to New Zealand's prime sawmill in Gisborne, where another fascinating chapter in modern lumber processing is being written. Gisborne, located on the east coast of New Zealand's North Island, is a region blessed with extensive plantation forests, and the prime sawmill represents the cutting edge of lumber processing technology adapted specifically for the unique characteristics of New Zealand's timber industry. The prime sawmill in Gisborne processes primarily this radiata pine, and understanding this species is key to understanding how the mill operates. Radiata pine grows remarkably fast in New Zealand's climate. Trees reach harvestable size in just 25 to 30 years, compared to 60 to 80 years for many softwood species in North America or Europe. This rapid growth means the wood has different characteristics than slower-growing species. It's generally lighter, the growth rings are wider, and the wood requires different processing approaches to produce quality lumber. As logs arrive at the prime sawmill, they're sorted in the log yard by diameter, quality grade, and sometimes by specific customer order requirements. Modern log yards like this one use sophisticated logistics systems to manage inventory. Each log might be tagged with a barcode or RFID chip that tracks it through the entire process, ensuring that specific logs destined for specific products end up exactly where they're supposed to be. This level of tracking was unimaginable in the old days, when log inventory was managed by physical sorting and the sawyer's memory. The debarking process at Prime uses what's called a ring debarker, a design particularly well suited to the relatively uniform diameter logs coming from plantation forests. The log passes through a ring equipped with blades or teeth that press against the bark from all sides simultaneously, stripping it away as the log moves through. This is faster and more efficient than tumbler-style debarking, especially when dealing with logs of consistent size. The bark removed here is collected and processed for landscaping products or used as boiler fuel, continuing that theme of zero-waste operations that characterizes modern sawmills. Before the main sawing begins, the logs pass through a scanning system that's even more sophisticated than what we saw at Soderham Ericson. The scanners at Prime use 3D imaging technology combined with X-ray detection to create a complete picture of each log's interior characteristics. The system can identify knots, detect internal defects, measure the angle of grain twist, and even predict how the wood is likely to warp or move during drying. All this information feeds into the mill's optimization software, which calculates the cutting pattern that will yield the most valuable combination of products from each log. The primary breakdown system at Prime Sawmill employs what's called a curve sawing, or profile sawing technology. This is a relatively recent innovation in sawmill technology that's particularly effective for plantation-grown logs. Instead of forcing the log to conform to straight cutting lines, the system follows the natural curve or sweep of the log. Many plantation-grown trees have some degree of sweep or curve to them. Traditional sawing methods treat this as a defect, cutting around it and creating waste. Curve sawing technology allows the saw to follow that curve, maximizing the yield of usable lumber from logs that previous generations of sawmill technology would have struggled with. The main saws themselves are high-speed band saws, each one a loop of flexible steel with incredibly sharp teeth moving at tremendous velocity. Bandsaw mills became popular in the mid-20th century because they cut a narrower kerf than circular saws, meaning less wood is converted to sawdust and more ends up as usable lumber. The bandsaws at Prime are equipped with automatic tensioning and tracking systems that maintain optimal blade performance. These blades are replaced frequently and sent out for professional sharpening and maintenance. In a high-production mill like this, blade maintenance is critical. A dull or improperly tensioned blade reduces cutting speed, produces rougher surfaces, and can even be dangerous if it breaks. After the primary breakdown, the resulting cants and boards move to the gang saw section, where multiple cuts are made simultaneously to produce boards of specific dimensions. The precision here is remarkable. The distance between blades is computer-controlled and adjusted automatically based on the cutting pattern determined by the optimization software. We're talking about adjustments accurate to within a fraction of a millimeter, ensuring that the boards produced meet exact specifications. One particularly interesting aspect of the prime sawmill operation is their focus on producing engineered wood products in addition to traditional dimension lumber. Much of the radiata pine processed here goes into manufacturing laminated veneer lumber, LVL, and other engineered products. This is part of a broader trend in the wood products industry, where technology allows us to take smaller trees and create structural products that perform as well or better than solid lumber from old-growth timber. Sorting at Prime Sawmill is handled by what's called a full automated sorting system. After boards are trimmed and graded, they enter a conveyor system with multiple drop points and diverters. The control system knows exactly where each board needs to go based on its dimensions, grade, moisture content, and customer order information. Boards destined for kiln drying are routed one direction. Boards that need additional processing go another way. Boards ready for shipment head to the packaging area. At any given moment, the system might be building dozens of different packages simultaneously, each one specific to a customer order. The kiln drying operation at Prime is extensive, with multiple kilns running continuously. Radiata pine, because of its rapid growth and relatively high initial moisture content, requires careful drying to prevent defects. The kilns use sophisticated control systems that monitor the temperature, humidity, and airflow at multiple points within each kiln chamber. Some kilns employ radio frequency or vacuum drying technology for special products that need faster drying or special treatment. The moisture content is monitored continuously, and when the target level is reached, that charge of lumber is removed and the next load goes in. What's particularly impressive about operations like Prime Sawmill is how they've adapted technology to their specific circumstances. New Zealand's timber industry is relatively young, without the legacy infrastructure and traditional practices that sometimes constrain innovation in older timber-producing regions. This has allowed companies like Prime to adopt the very latest technology, often implementing systems and approaches that are still experimental or uncommon in more traditional sawmill regions. They're not constrained by having to retrofit old buildings or work around existing equipment. They can design their operations from the ground up to maximize efficiency and production quality.